OpenAI's new model O3 is outperforming 99.8% of all competitive programmers. Now, this is on CodeForces, which is the world's most popular competitive programming platform. And if you're a software engineer, this result should worry you, because this shows that the new reasoning models of OpenAI and various other organizations are starting to solve problems which were earlier exclusively human. So stick around till the end of this video. You learn a lot. Let's go. All right, let's start with the competitive programming side of things. For a long time, companies have been trying to build an automated competitive programmer. This started with Google. They had something called AlphaCode, and recently they had an improvement with AlphaCode 2. If you know about AlphaGo, which played the world champion on Go and won, AlphaCode is using the base model and then training itself on huge sets of submissions, which are basically code for competitive programming contests, running them through a MapReduce pipeline, doing some sort of reinforcement learning, and trying to get a decent result. This was not very efficient in the sense you would have this massive training process, and at the end of it, you would have a model which would get 85 percentile on CodeForces, which is roughly 1600 in rating. So a human being with little training, maybe a month of training, can actually beat this model. So it's not very impressive, but it's a good benchmark. After this, you had O1, which is better. It has a 89 percentile on CodeForces, 1600 to 1700 rating. Internally, O1 is expected to use MCTS, Monte Carlo Tree Search, the same thing that AlphaGo used to beat the world champion, human world champion. And it is also expected to use long chain of thought. Chain of thought is a basic practice where while training the model, you explain to it what you are doing. So an example would be, give me the answer for 35 divided by 14. As a human, you're probably looking for factors. That's the first step. So you find a common factor 7, you see this is 5 by 2. As a second step, just look at the quotient of this division. Okay, so that can be the second step. And then you're looking at the remainder, which is 1 by 2. So the final answer is 2.5. This would be a chain of thought. While training the model, it's been noticed that if you give the model enough time to go through these chains, if every example is understood in a good way, then the knowledge of the model or the intelligence of the model increases. And this has been independently verified by Google, by DeepSeek, by OpenAI. So what seems to be the case now is the longer you can make these chains, the more complex thought you can come up with. A recent paper, again by Google here, Alpha Geometry 2, actually beats nearly all humans, right? It's again got a world rank of, I think, 69 out of 600 mathematicians in the International Mathematics Olympiad, which is IMO. And that paper just came out like a week ago. And to improve on this, OpenAI took the existing O1 model and fed in a bunch of difficult IOI problems. They saw that the model performance improved, right? So you had this general O1 model and you used specific competitive programming problems to fine tune it. The performance improved from 1600, the rating, to 1800, which is 93 percentile. For further improvement, the O1 model took around 10,000 submissions for each problem, and then it tried to find which submissions make the most sense. So if all the test cases for two programs match, so if you pass the first 10 test cases and fail the next 10, and another solution does the same thing, then you take both of them and you consider them to be equivalent, you put them in the same cluster. Each of these clusters is going to have a score. If you get 10 right and get 10 wrong, then you're probably at 0. If you get all 20 right, then you're at a plus 20. And if you get everything wrong, you're at a minus 20. So the ones which have minus 20 need to get that reinforcement, the negative reinforcement that you suck, you really have to improve. And so the model is going to be changing the weights accordingly. The ones which get a plus 20 score are awesome. The model is going to again change the weights accordingly. It's going to say, this is great, keep the weights. And then you take the solution from the highest scoring cluster to make your submission. With this, O1 IOI with full test time strategy got a score of 2200, which is 98 percentile on CodeForces. So out of 100 competitive programmers, you're in the top 2. But then O3 came along and completely smashed these benchmarks. It has a rating of 2700 plus. which is 99.8 percentile on CodeForces. It's not in the top 2 out of 100, it's in the top 2 out of 1,000 competent programmers. Right? There's in total around the world, there's less than 200 people with a rating higher than that. The whole of United States has like 7 competent programmers who have a rating higher than O3 right now. And the entire country of India has 1 competent programmer from IIT Kharagpur who has a rating higher than O3 right now. Now, I forgot to mention one thing here. O3 does something which is creepily human. In the sense, if you have a difficult problem to solve, what it does is it first finds a brute force solution. Brute force solution, let's say, is running in order n square, time complexity. And this brute force solution is used as a judge for future optimized versions. As a competent programmer, I used to do this, right? I used to write a brute force solver. Let's say it's order n square. I don't really care. I'm not trying to pass all the submissions. I'm just trying to create a solver, a tester, which I can run locally. Then what I do is I write an optimized version of the algorithm, but that optimized version is a bit complex. It's not easy to get right in the first go, and you are not even sure if that is actually correct. So what do? You take the optimized version, you send in a test case, and you send in the same test case to the brute force solver. If both of them give you the same response, you know that the brute force solver is correct. That means your optimized version is also correct. So that used to build my confidence, and I could also basically make changes without any regression, right? I got to know of the regression term later as a software engineer, but competent programmers do this all the time. They have a brute force solver, they have an optimized version, and they can further optimize that version without worrying about a regression. Now, if O3 can come up with this strategy by itself, it means that it's not only able to do things like a monkey, pulling a bunch of levers, it's actually able to derive strategies from its play. If you have seen how AlphaGo worked, it played millions of games with itself. Eventually, it got better than the best human in the world. And that's what's happened here with competent programming. It's played millions and millions of games with itself till the point that it understands what competent programming is as a concept. And now it is able to actually generate solutions better than humans. And there is no reason to believe that this trend is going to stop, that this model is not going to get much smarter, because as you scale up test time, as you scale up inferences, models keep getting better. The scaling law for large language models is absolutely brutal. If you spend 10x the time on compute, then you can expect maybe 2x the intelligence. And that's not so crazy to think of, right? The 2x the intelligence, you're going to beat a lot of people. Is there any competent programmer who's 2x as smart as the person at number 100, number 200? Like if you look at tennis, right, the top 100 players are all considered really close to each other. Even in computer programming, it is really, really close at the top. Consistently, some people perform better, but it's not that they're much, much smarter than the other people. It's just that consistently they end up getting results faster and better than the people below. So if OpenAI or Google or any other company can actually raise the bar, then we will probably see the end of excitement in computer programming when it comes to humans. Okay, similar to chess, where yes, you have lots of humans who can play chess really well, but computers, including my cell phone, can actually beat Magnus Carlsen, right? Because of the advancement in algorithms and just the way that these computers work. They're much, much faster and can see a lot deeper. Now, some of you who are not computer programmers might be wondering, how does it matter? This was never a real test anyway. It was just a monkey problem. It was just a coding problem that people used to solve. I don't do binary trees. Well, OpenAI has actually worked on something called HackerRank Astra, which is a set of problems which are real world based. So you have multiple files, you have a task to do, which is very similar to software engineering in the real world. And it's got state-of-the-art scores here. Like 70% of the problems can be solved using this large language model. They're now starting to call it a large reasoning model. And you can see why, because a lot of this is actually human comparable performance. Software engineering, which is a very abstract field, is having a large set of problems, and these models are tending to perform at par with humans. And to bring the point home, they have another benchmark called SWE Bench. This is custom built by OpenAI. I can guarantee you they have used it for recruitment at some point in time. So they have a bunch of, again, real world problem solving skills for software engineers, tests based on them. and they asked the model to solve these problems to get a 70% solving rate again with O3. So it's interesting to think of, because when you look at the logic behind these results, it's like, as long as you can tell if a solution is correct or not, the model, through reinforcement learning, trains itself, keeps playing against itself, and eventually finds a path which is sensible, right? So as long as you have a bunch of test cases which can tell you whether this is correct or not correct, and you have a clear goal to get to all test cases being solved, the large language models are so smart that they are able to learn through reinforcement learning the things that they need to do, the weights that they need to adjust to actually reach the goal state. Now, if you're a software engineer, I'm sure this is concerning you a little bit, especially if you're young and in university. You might have been doing computer programming to get job offers. You might have been doing lead code to better understand data structures and algorithms, but also for a job offer. It seems like this space is going to die very quickly, right? Because as computers get better and better at this, plagiarism and just solving the problem using an LLM is going to be trivial. So I see a serious movement away from these kind of mathematical, extremely sanitized problems to more real-world, practical, hands-on problems. So not only are we going to have more problems in this space, but I also think that there's going to be more focus. Various companies like Google and definitely OpenAI have already moved to these kind of problems. And although you do have a lot of data structures and algorithms, we are going to be moving as an industry to more complex ways of evaluating a candidate. So thank you for listening. If you have any comments or opinions, please let me know in the comments below. If you are looking for the link for this paper, I'll be sharing it in the description. And also have an awesome system design course at InterviewReady, all taken by me. It has hundreds of videos on system design concepts like load balancing, routing, message queues, and then it also has high-level design questions. There's also a low-level design course which talks about design patterns, about the solid principles, and machine coding, which might be the last bastion when it comes to software engineering interviews. So check it out. Let me know what your thoughts are, and do let me know your thoughts on this video and the paper. Thank you so much for watching this. See you. Bye-bye.